Factors affecting performance. There are three main factors affecting performance: weight, wind, and density altitude. Here, when we talk about performance, we mean the effectiveness of the aircraft or the airplanes to perform normal operation like takeoffs, rate of climb, cruise performance, fuel consumption, cruising speeds, landing distance, etc. etc. Weight. Increase in weight is a penalty for performance because now we need to produce more lift to support the extra weight. To produce more lift, we would have to use more energy. We would have to give more energy to producing lift. This energy could have been used to produce more thrust for us to go faster, reach our destination faster, consume less fuel. But now we are using this extra energy to produce lift and support the airplane in the air. Also, heavier airplanes take longer time on the ground before lifting off, meaning we need to put in more energy to accelerate those airplanes to a lift-off speed. And on the other hand, when landing, they need a longer distance to come to a stop. So, basically, with the remaining conditions staying the same, a lighter aircraft will perform better than a heavier aircraft. Then comes wind. Wind is the motion of air. Now, winds have different roles at different flight regimes. For example, you need a headwind for takeoffs and landings, while you need a tailwind, while you would prefer a tailwind for cruising because that would increase your cruising speed. A headwind on takeoff or landing can reduce the ground roll that is required to accelerate, or on the case of landing, to stop. A tailwind, on the other hand, for takeoff and landing can significantly increase the ground roll. We must always try to take off from a runway with a headwind for better performance. On the other hand, when you are cruising, a headwind will reduce your ground speed and hence increase the time it takes to reach your destination, increasing the fuel consumption and degrading performance. This can also cause delays of flights, so we try to look for a tailwind at our altitudes to fly faster ground speeds. Density. Density is a huge factor in performance in all of the performance calculations. We use density altitudes to measure the density of air. Lower air density is bad for performance. Let me explain why. Take the Cessna 172S for instance. It has a normally aspirated engine, meaning it takes the outside air as it is for the process of combustion in the cylinders. If you have less dense air going into the cylinders for combustion, the effectiveness of combustion is reduced, hence less energy is produced for the given amount of fuel as compared to that of high density air going into the combustion chambers. Similarly, the wings need high density air to produce sufficient amount of lift. If you remember from our chapter of aerodynamics, the lift equation had density of air as one of the factors in it. If the density of air is decreased, the lift is decreased. And now to compensate for the decreased amount of air density, we will need to fly faster through the air to produce the same amount of lift. And this means that we will have to use more thrust, more fuel, and hence bad performance. And now if you think about it, all of the remaining airfoils like the propeller, the tail, will not perform as good in a low density atmosphere. Decreased air density affects all the flight regimes, but the effects of low air density on performance are more apparent during takeoffs and climbs. When altitude is corrected for non-standard pressure, it is known as pressure altitude. When pressure altitude is corrected for non-standard temperature, it is known as density altitude. At standard temperature, the pressure altitude is equal to density altitude, which rarely happens. On a hot summer day, the density altitude of any given airport can be as high as 2000 or 3000 feet higher than the field elevation, and as a result your airplane will perform as if it is flying at those higher altitudes. Density altitude differs from field elevation whenever the temperature differs from the standard temperature, which is most of the time. If you know the field elevation, altimeter setting and the outside air temperature, you can use this chart to find the density altitude. You can also use this formula and get the exact value of the density altitude. The density altitude is the altitude where the airplane feels that it is flying at. We know that air density decreases with altitude, and so does the performance. Performance of an airplane decreases with altitude as well. This means that if the density altitude is higher than your field elevation, you can expect bad performance. The further the density altitude goes above your field elevation, worse the performance gets. Factors affecting density altitude. Atmospheric conditions can decrease air density. For example, pressure. A decrease in pressure can create less number of molecules per cubic volume, hence decreasing the air density, increasing the density altitude. After pressure, you have temperature. If temperature increases, the air becomes less dense, hence increasing density altitude. And the third factor affecting density altitude is humidity. Water vapor is less dense than air. If you add water vapor to air, the air becomes less dense. Hence, increase in humidity will decrease the density of air and increase the density altitude.